Good evening everyone. Welcome back to our channel Diksha Karnataka. Today I'm here to discuss the one short lecture of the chapter Relation and Functions. Let's quickly check whether I'm audible and visible or not. Yeah. Yes, so clearly. Yes guys. Just let me know in the comment, in the live chat, whether you all can hear me, right? So first of all, good evening. I hope all of you are doing great. Yes, Sahana, how are you? Hello. Yes. One second, guys. 1 second. Can you hear me, Sahana? Yes. So, good evening, good evening, good evening. So, I'm gonna start with the first chapter itself, which is relation and function. So, I'll discuss all the concepts in this chapter alongside questions which is there which we can learn at the same time with the concepts, and we'll solve some PYQs also from the CET point of view, and I'll give you few questions as homework because I want to know how many of you are seriously studying in the upcoming classes. Okay, I would like to know the response of all of you. Yes, so guys, am I clearly audible? Just let me know about that. Can you all hear me properly? Anything wrong with the voice or anything in technical aspect? No, right? Yes. Yeah, great. So okay, so let's start the class itself. If you guys have any concerns, certainly you can put it in the live chat. I'll continue itself. So the chapter is very to the point, not much, because if you talk about the chapter as a whole, yes, few concepts of PU1 is also there, that comes hand to hand. For example, the concepts of what is a relation. Okay, so relation is what? The ordered pair you make from any two given sets, or on any one given set also we can make when you're defining a relation from the set itself, means A to A, right? So let me just give you a brief on that. If you just talk about just relations, okay, then we can define relation from set A to set A also, and set A to set B also. Means when we have two sets given, I can define the relation, let's say a relation R1 for this, and I can define the relation R2 also on the set A to A itself. So what is the relation going to be? So basically you take the elements of set A. For example, if I take the set A as having the element 1 2, set A has the element 1 2, and I'm defining a relation, let's say, what is it, R2, from where to where? From A to A, from A to A. Then the ordered pairs that we get will be like what? The relation will have the ordered pairs like this. I can manage 1 with 2, 1 with 1, right? Or I can go with 2 with 1 and 2 with 2. That's the all possibilities for me, isn't it? Means if I define from A to A, so A will have elements 1 and 2, so is the other set A will also have the element 1 and 2. And when you take the Cartesian product of two sets, remember the statement, Cartesian product of two sets, you'll have these ordered pairs formed. So the relation can be defined in all these elements, or any of, I can take only one element and define the relation. So I can have different type of rules working. That's how you make a relation, right? Is it clear? So this is all from the PU1 side, not from the PU2 side. In PU2, teacher has to understand that you already know what is a relation. Clear, guys? Is it clear? So I hope I am going to take the understanding that you already know what is a relation, and from there I'm going to move on to what is there in this year's syllabus, which is what? The types of relations. And we have few basic ones like empty, void, universal, but majorly we have three types which is useful in our syllabus and question solving, that is reflexive, symmetric and transitive. Yeah, so for the question point of view for this year, these three are the ones that matters the most. Okay, all right, so this is, I think, the basics part of what is a relation. Okay, so let me just erase this right now. Okay, yeah, 1 second guys, something, yeah, yes, okay. Coming back to the statement, types of relations. So first type, excuse me, 1 second, sorry, the OBS was not visible. Okay, clear. there's some problem, I solved it right now. Okay, coming back to the first slide, we have empty or void relation. So relation R on a set A is called as empty if in the relation there is no element, present in the relation, then the relation is called as empty or void relations, right? So if I have to define it over here, let's say the set is defined here 1, 2, 3, 4, 5. So elements of the set A is defined as 1, 2, 3, 4, 5. And the relation is defined on what set? Check here, A to A if I'm defining, means basically if I have to write a relation, I'll write like what? Like this. Relation is defined from set A to A. In that case, the rule is saying that difference of the element. So if you take the ordered pair, the difference of the element has to be what? 5. You check any of the element, this is not satisfied. If I check 1 and 4, if I check the smallest and the largest, means let's say 1 and 4 or 4 and 1, what is the value? -3 over here, this is 3. Is it equal to 5? It's not. Means for no two combinations, for no two such combinations of the element in this set A, I can have this rule established. It means in the relation R, if I'm writing, I'll have no ordered pairs. I'll have no ordered pair, hence it is called as empty or void relation. Good evening, Sahana. Okay, so is this clear now? Yeah. So we'll try to understand each of them one by one. The universal relation means basically it'll be possible to write what? A relation R on the set A is called universal relation if each element of set A, okay, each element of set A is defined to will be able to form relation with each, like all the other element in set A. Okay, for example, take the condition over here. So it's saying that if I take example over here, set A is defined as 1, 2, 3. Set A is defined as 1, 2, 3, and the relation is difference of any two numbers or any two element when taken modulus, means absolute difference, means only the magnitude part is always more than 0. Take example 1 minus 2 mod, 2 minus 3 mod, 1 minus 3 mod. What is this, sir? 1. 2 minus 3 is again 1. 1 minus 3 is what? 2. Take other way around, 3 minus 2 is 1. 3 minus 1 is 2. So in whatever way you take the two elements and find their absolute difference, means the magnitude of the difference, you'll get a value which is always more than 0. It means each and every element in the given set is related to the other element in the given set, each and every element of the set. That's why it is each element of set A is related to every element of set A. In that case, the Cartesian product of the set A cross A will be what? Will be a universal relation. Yes, guys? Okay, great. So this is why it is called as universal relation. Let's move on to identity relation. Now this is from where our critical things start. We have to learn this very well so that we can apply in the reflexive relations. Okay, so what is identity relation, sir? So the relations which are, means if a relation is defined on any set A, for example on this one, 1, 2, 3, okay, then the relation that you're writing, let's say I'm writing a relation R, okay, then in this relation I'll have the elements related to itself, means 1 is related to 1, 2 is related to 2, and 3 is related to 3. So 1, 1, 2, 2, and 3, 3. This is what is written over here also. So when you are writing a relation where the elements is related to itself, the word is itself only, means if I try to write here 1, 2 in this, if I write an ordered pair 1, 2 in this relation, it will not be relation which is called identity anymore. I have to write itself only, means 1 related to 1, 2 to 2, 3 related to 3. I hope this is clear. Yes, great. All right. So guys, if you are able to understand what I'm trying to say over here, you can put a thumbs up or whatever it is. Yeah, you can let me know by putting some hearts or any type of emotion, smiley ones. Okay, if you're having some doubt, try to ask that as well. Okay. All right. So just because it is a one-shot session does not mean that I'll rush things. Okay, because the chapter has 1 to 2 questions coming from this particular chapter 2 in your examination, and those two are either one on equivalence relation, which is the types of relation, and second one will be types of functions. So these are the two categories. So we'll try to keep our lecture surrounded by the concept which is going to be helpful to us in getting these marks. Okay, now next is reflexive relation. Now from here the actual portions from where the question are asked starts. Reflexive relation, so this is basically identity relation. This is basically the identity relation and extra. So I'll show you what. So if I am defining this on the set A, 1 2 3, so I have to write that relation. First of all, let's say I'm writing relation R1. The ordered pairs will be written here. So 1 1, 2 2, 3 3, 2 2 3 3. So if I write this much and I ask you, is this relation a reflexive relation? Your answer will be yes, because the notation to represent this relation is given like this: A R A, means all the elements A which belongs to the set A should be related to the element A itself. Okay, so that is the definition of reflexive relation: A R A, where A belongs to the set A. All right, guys. But if I add something extra also, for example, if I write another relation on the same set, I can have more than one relation, okay guys, on the same set. In this, if I write here 1 1, 2 2, 3 3, and if I write here, let's say 1 2, and I ask you, so this was a reflexive relation, this was a reflexive relation, what about this? Also reflexive, sir. Also reflexive, sir. So basically, if as long as this is present, for all the elements of the set, it'll be a reflexive relation. For example, next one, let's try two more examples. Okay, let's try two more examples. So this is R1, R2, let's write R3, 1 1, 2 2, 1 2, and 2 1. My question is again whether it is reflexive or not. So please tell me, everyone in the live chat right now, whether this is reflexive or not. R3, yes or no? R3 reflexive or not? Yes or no? I would like to see your comment. Come on. I hope you can see that. R3, 1 1, 2 2, 1 2, and 2 1. Is it reflexive, guys? Is this reflexive? Anyone? Come on, let me know. Sahana? Yes, any answer? Okay. As I mentioned already, for all the elements of the set A, there must be the relation of A comma A. This should be always present. A comma A should be always present. Whereas, you can see here 3 comma 3 is missing. Okay. So, extras are welcome, but A comma A for all the element must be there. So, for this relation, you write not possible. So given relation R3 is not reflexive. Yes, correct. Now if I write relation R4, where it is, let's say 1 1, 2 2, 3 3. If you write 4 4, is it possible to write 4 4 also, guys? It's not possible, because 4 does not exist in this set. So whatever relation you're writing the relation on the set which is defined, okay? But that is not defined over here. So I cannot write elements of my choice without present in the set. So if I write just this also, if I write, let's say just 1 2 and 2 1 again, then this will be a reflexive relation. This will be a reflexive relation. Great. So I hope this is clear. So reflexive in the reflexive relation, identity part must be there, but extra cannot be there. Okay. So if I call you to tell me this is reflexive or not, your answer will be reflexive. Yes, sir. Identity or not? Yes, sir. What about this one? Reflexive? Yes, sir. Identity? No. For identity, only A comma A should be there. So here A comma A is present, that's why it is both true. But in this case, A comma B is also present, means something extra is also present. That is not identity anymore, only reflexive. So reflexive, yes, but identity, no. I hope this is clear. Okay. Now symmetric relation. This is a simple one. So for reflexive, I wrote ARA. In this case, I'll write. Remember here, everything is related to what? The ordered pair, guys. The ordered pairs. So ARA means what? ARA means the element A is related to A, and for that ordered pair is A comma A. But ARB means element related like this, A comma B, A comma B. Okay, so for symmetric relation, what you go with this? If it is a if and then condition, if ARB is true, then BRA also must be true. Means if in a relation, let's say I write a relation R1, okay, where the ordered pair AB is present and BA is not present, then it's called not a symmetric relation. But if AB is present and also BA is present, it becomes a symmetric relation. It becomes a symmetric relation. Check carefully. Again, set A is defined 1, 2, 3. 1, 2 is there, 2, 1 is there. Okay, sir. 1, 3 is there, 3, 1 is there. Okay, sir. Sir, what about 2, 3 and 3, 2? We will not check for that. We'll only check for what is present over here. In case of symmetric, so in reflexive, what was there? For all the element, A comma A should be present. I said that, right? For the reflexive relation, I said for all the elements. Here, 3 comma 3 was missing. I said it is no longer reflexive. But in the case of symmetric, what I'm saying, only for what is given in the relation, we'll look for that. So, if you have 1, 2, 2, 1 must be there. If you have 1, 3, 3, 1 must be there. Okay, so let me just write some examples. R1 is there, R2. So if you have 1, 2, 2, 1, 1, 3, R3, 1, 2, 2, 1, R4, 2, 3, 3, 2. So if I write this three relations, R2, R3, R4, it is symmetric? No, because if 1, 3 is there, 3, 1 must be there. It is not there, so it is missing. 1, 2, 2, 1, yes. 2, 3, 3, 2, also yes. So we'll look for only if and then condition. We'll not look for, sir, what about other elements? There's no question like that. In symmetric, we only look for the ordered pair which is present. If AB is there, then BA should be there. So AB, BA. What about this one, sir? If, let's say this is AC, but CA is not there. Hence it is gone. Okay? I hope this is clear. Hi Aki, how are you? I hope you're doing good. Yes. And also you have gained weight, sir. Okay, fine. I'll get back to the setup and lose weight at the same time. Okay, I'm doing good. Yes. How are you? So you're busy with the process of counseling, right? I guess. Yes. So everyone, Aki is your senior. He was there in our last year's batch. He was studying with me maths. Yeah, one of the good student. I really wish him all the best, and he continues with his great preparation and continues with his engineering. Okay, Aki, you're going for engineering only or medical sciences? Great, great. Good to hear. Yes, so symmetric relation is clear. Anybody has doubt in symmetric relation so far? Because it is very critical to understand the concept behind it, okay? You might think this is just numbers and blabbering and you might skip it. You might not find it important, but I'm telling you, when you look at the questions, things will come back. That's why I brought some PYQs with me. When you see the PYQs, okay, yeah, so this makes sense. Okay, so if you have anybody has any doubt, I'm here to help you in the case of symmetric and reflexive. Go ahead and ask me. I'm going to start the transitive part, the most trickier one that you guys miss out on. Yes. Good, all the best. Yes, sir. Yeah. Okay, going for engineering. Great. Be aware of the new technology. Never be just focused on the curriculum of colleges. You have to push the best from your side to be a proper, proficient, skilled engineer. Okay, just the curriculum will not be sufficient, because you know how fast the technology is changing. So you got to keep yourself updated. And so people used to say that, and it was the case 5-6 years back, where you just go into a college, you get a decent package. Okay, but now technology is changing very fast due to the presence of artificial intelligence. You got to be on your toes for next 4 years and make yourself advanced to learn all the concepts and all the technology that is around you. Okay, so wish you all the best and do that, please. Yes. And yes, guys, so anybody has any doubt in the previous two concepts? No? Then I'm moving ahead with the one where it tricks you a lot. Okay, transitive relation. All right. So First one was presence of ARA, sir. ARA means presence of the ordered pair A comma A everywhere for all the elements. AA for reflexive, everywhere for all the elements. For all A belongs to the set. For symmetric, sir, we have if condition. If AB is there, then BA must be there. Now for transitive, it is two if conditions. For transitive, it is two if condition. And what is that? The if conditions are like this: ARB and BRC. What we have? ARB and BRC together. When you combine them, that then becomes your then statement, which is ARC. So if you look at the ordered pair, this is A comma B, guys. This is what? B comma C. And if you combine them, it becomes what? A comma C. It becomes what? A comma C. Glad to hear that, Aki. Okay. Of course, everything that you guys do to show us appreciation really motivates us, okay, and keeps us on our edge to help you out, okay. So glad to, and very nice to meet you here in the live chat. All right. So yeah. So this is the definition of transitive relation. Starts from two if conditions, goes to the then condition as AB, BC and AC. So basically you combine these two and you get AC as the ordered pair. So if all the three are true at the same time, means in the relation, if all three are present, so if I write a relation like this, let's say, if I write a relation like this, R1, okay, and in R1 if I write that AB is present, sir, BC is present, sir, and AC is also present, sir, then this becomes a transitive relation. Example, have a look. If I write, sir, let's say 1 2 2 1, okay, then I must have 1 1. 1 2 2 1 and must have 1 1. If I want, I can write this as 3 also, no problem. I can write this as anything, okay, just that this element has to be what? 2 only. Then answer is what? 1 3. If all three are present, it becomes a transitive relation. But if even one of them is missing, let's say I don't have this, then this will be no longer a transitive relation. So I must have all the conditions valid at once. AB, BC, AC must be there. Okay, that's how you remember transitive relation. Now very few important points about this particular relation is, if you cannot make, let's say for example, if I have a relation R1 which has only this, or R2 which has only, means if you cannot check for obstruction in the relation for transitivity, means if you cannot say it is not transitive, can you say right now it is not transitive? Is there a way to say it is not transitive? Because for a relation to be not transitive, I must state this statement and say it is not valid, right? Means like, sir, AB is there, BC is there, but AC is not there. If that is the case, then I can say it is not a transitive relation. Yes? Okay. But in this case, can you define that? Can you justify that? Of course no. So for all those relations where you cannot, listen to me very carefully, this is very, 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 very important. For all the relations where you cannot justify or clear the obstruction in the transitivity, that becomes automatically transitive. If you cannot prove that it is not transitive, it becomes automatically transitive. You can't say, sir, I don't have the element only to verify it. Yes, that is enough. If you cannot do that, it is automatically a transitive relation. Am I clear? Okay, so now some lovely comments are coming. Hi Kishan, how are you? Thank you for your love. Thank you for your love, guys. Really, really appreciate your time that you are coming in, even though you are not part of the lecture. But thank you for your love and appreciation. Thank you so much, Kishan. Okay. So if, I'll repeat again, one way to define a relation which is transitive is AB, BC present and AC is also present, transitive. Good. If it is missing, sir, then not transitive. Very good. Next one, if you cannot say that it is not transitive, means I cannot find the relation definition over here, then you have to assume you have to always say that there is no way to prove it is not transitive, hence it is always transitive, sir. But not in the case of, that we have more elements, sir. I'm not able to check only. For example, sir, we have 1 1, we have 2 1, okay, we have 1 2, all right, and let's say we have we have 3 2 and we have 2 2. We have 2 2. Then is it a transitive relation or not? Let's try to check this out. Okay, let's try to check this out. So 1 1, will you check? 2 1 and 1 2 is there. If you club them together, it becomes automatically 2 2. So this is present, sir. If you take 1 2 with this one, it becomes 1 1. Check. If you take 1 2 with 2 1, it becomes 1 1. That is also there, sir. If you take 3 2 with 2 1, it becomes 3 1. And from this combination, 3 1 is missing. 3 1 is missing. So try to take combinations over here. So over here, you have to find out whether it is true for all elements or not. Yes. You cannot say just because, sir, I'm not able to find out on my own, I'm not able to figure it out on my own, that's why it's not transitive. Not the case. You got to find out and check for all the relations. Okay. So in this case, clearly, if you write here 3 2 first and write here 2 1 next. If you're thinking, sir, 2 1 is written first over here, the order is not important, bacha, in this case. Okay, you have to try all the iterations. Okay, 2 1 3 2 also, and 3 2 2 1 also try again. 3 2 2 1. What is the relation over here? The next ordered pair will be 3 1. Is 3 1 there? No, hence not transitive. Let's try this one. 2 2 and so 1 2 and 2 2. What about this? This will give me 1 2 only. If you take this over here, it will become 1 2. So transitive. Let's try now 1 2 and 2 1. So this is 2 1 and 1 2 written. For 2 1 1 2, answer is 2 2. But if you write here 1 2 and 2 1, what is the answer for this one? 1 1. And luckily this is present over here. This is present over here. Let me write another case for you. I know. So if I write here, sir, 2 1 and 2 1 and 1 2 and 2 2. 2 1 1 2 and 2 2. 2 1 1 2 and 2 2. Transitive or not? I want answer from all of you right now. Yes, I'm doing well. Thank you, Kishan. Guys, everyone in the class who's watching this particular question, let's say this is relation again R5. 2 1 1 2 and 2 2. Transitive or not? Please let me know. Please let me know, guys. 2 1 1 2 and 2 2. Transitive or not? Please, I want the answer from all of you. Sahana is saying yes, sir, it is transitive. Sahana is saying, Sahana is our student in the class today, is saying transitive. Anybody has any other answer? I want to look at the answer if you have anything. No. So only one answer I've got. This answer is wrong, by the way. Okay. So of course this is valid, sir. You only taught, sir, AB, and if it is, sir, B, in this case BA, then yes, sir, it becomes what? This becomes, sir, A. Good. True. Very good. What if I write the relation like this? 1 2 and 2 1, and check now. It becomes 1 1. Is 1 1 present? No. And what happened? You lost 1 mark. If it is MCQ of PU boards, you lost 1 mark. If it is a KCET question, you lost 1 mark. So you got to try this iteration also. You cannot say, sir, this order is not given in the question, sir. They said 2 1 1 2. You're writing 1 2 2 1. Order you can change. You got to check for all the iterations. So 1 1 is not there. 1 1 is not there. Hence it is actually, what is the answer should be? The answer should be not transitive. Is it clear now? But if I write another relation R6, check now. If I write here 1 1 2 1 1 2 and 2 2. What about this one then? One, 2 and 2 2. What about this one then? Tell me. If 1 1 is present, now it will be transitive. Getting it? So this is the tricky part, and student make, because in the question they'll ask for reflexive relations. So there is a trick how to find out. First one is the definition, AB, BC, AC. Good. Second one is if you cannot create the objection. So first category was this. Second category was this, if you cannot create the objection. And the third category is this one. What is this? If you have A, AB and A, AB, and this also is there, BB is also there. Okay, if you have A, BB and AB, never check, it is always transitive. Here also, if you have A, BB and AB or BA, so if you have guys AA, BB, AB or same thing, just BA, will always be transitive. This is a transitive relation. So you never check, never have to check. If you have A, BB and AB, never check, always transitive. For all other cases you have to check. Check here. Here you check. So A, BB. What is this, bacha? This is AA. And what is this? BB. A, BB. What is this, bacha? This is BA. And what is this? AB. That's why don't even check for this. This is always transitive. Clear? So if you have the presence of A and BB together and you have BA and AB, never check, always transitive. Always transitive. Otherwise you have to check. So basically this transitive relation is something that can take time in the questions. So I'm trying to give you those simple understandings of the concept which can help you solve the questions faster. So first understanding is what? Try to look for directly this part where a definition is clearly working or not. If it is not working clearly, it is messy, then try to check whether this works or not. If this also does not work, try to check whether this property works or not. If it works, good. If it does not work, then you have to do the crude work and check for individual element one by one, the way I checked over here. Clear now? Okay. So this was it. Now the combination of all the three. If a relation is ARA, what does this means? What is this, sir? This is ARA. ARA means reflexive. What is this one, sir? This is the condition for ARB and BRA. And what is this, sir? This is, say, all the three. ARB, BRC and ARC. So reflexive, symmetric and transitive all together for a given relation which is reflexive, symmetric and transitive. The combination is called as equivalence relation. That's it. Nothing extra is there in this particular concepts. Combination of all at the same time is called as equivalence relation. Okay. Now number of relation. This is important formulas for your CET point of view. These questions are not asked in your boards, okay, but for CET they can ask time to time. So please you have to remember and keep a note of this. All right. So number of reflexive relation. Number of reflexive relation is given by 2 power n times of n minus 1, where n is what? Number of n is the number of element, okay, in the given set. Okay. For any set A, the number of element is what? If it is n, so if the cardinal number of the set, let's say A, is n, then the number of reflexive relation is given by 2 power n times of n minus 1. Number of symmetric relation is given by what? 2 power n times of n plus 1 by 2. This is what? Symmetric relation. This is what? Symmetric relation. A number of relation on a set which has what? Both reflexive and symmetric. Okay, which has elements which are both reflexive and symmetric is given by 2 power n times of n minus 1 by 2. Okay, by 2. So these are the 3 important formulas, 1, 2 and 3. Please take a note of this, very, very important. Okay, yes. Excuse me. Yeah. Now let's solve a question on. For the set A, 1, 2, 3 is the element. Define a relation R on the set A as follows. Okay. 1 second, guys. Okay. Yeah. For set A, 1, 2, 3, define the relation R on the set A as follows. 1, 1, 2, 2, 3, 3, 1, 3. How many ordered pairs to be added to make this relation smallest, word is very important, smallest equivalence relation. Okay, to make this relation smallest and equivalence relation, what is the number of ordered pair to be added? Okay. Answer please. If I call this question number 1, what is the answer for this question? Please let me know. A. Amina is saying answer is A, and that's correct. And what is that element? Of course, you can see, sir, 1, 1 is present, 2, 2 is present, 3, 3 is present. Once that is there, reflexive is sorted, sir. So for this, will we check for symmetric? Of course not, because 1, 1 and 2, 2 are always symmetric only. Since 1, 3 is there, sir, my 3, 1 is missing. So if I add 3, 1 over here, now it is symmetric also, right? If I add 3, 1 as the ordered pair, it is symmetric also. Now what is missing now? Let's check for transitive relation. So whenever I said that AA, BB is there, sir, sorry, not here. This is not BB in this case. This is the BB. A is there, sir, BB is there. Then this is what, sir? AB, and this is what, sir? BA. What did I teach you? If you have AA, BB, AB, BA, never check, always transitive, always transitive. So what about this element, sir, CC? Can you, so for, sir, this element, it is, sir, CC. Can you create objection for this? You cannot create objection for this. It means automatically it is a transitive relation. So all of these are combined. So after adding this element, which is what? 3, 1. Once we add this in the relation, the given relation becomes what? Equivalence relation. Hence my answer is I need to add 1 element. They're asking us number of ordered pairs. This is only 1 ordered pair. So my final relation is this, sir. 1, 1, 2, 2, 3, 3, 1, 3, and 3, 1. And this is what we have added. We have added 1 ordered pair. Hence answer is 1. Clear? Yes. Good job, Amina. Sahana, I was looking for your answer also. Yes. Correct. On the set n of all natural numbers, define the relation R by A or B if and only if GCD, the word is GCD, what it means? Greatest common divisor. Greatest common divisor. Difficult name, it is basically HCF, where the highest common factor of two numbers A and B, of A and B is what? Is 2. So they are saying that when HCF is 2, and what is the set? It is defined on natural number set. For natural number set, what is the element must be? Should be 1, 1, 2, 2, 3, 3, and so on, right? We'll have many elements, of course, but this must be there. So for 2, 2, what is the HCF, sir? For this, HCF is 2. Great. But for this, sorry, what is the HCF for this? 1. But they are saying HCF must be 2. Must be 2. I am getting HCF in this case 1. Is this should be there in the relation R? Yes, it must be, because it says that define on the natural number set, all the natural number will make, for it to be reflexive, I should have ARA for all the elements. Reflexive means what? ARA or A comma A. So for 1, for 2, for 3, for 4, it will never end. Of course, it is an infinite set only. But can it be reflexive? It cannot be, because it's saying the GCD or HCF should be 2. For this it is 1, for this it is 3, for 4 it is going to be what? 4, 5 will be again 1, 6 will be what? 6, and so on. So reflexive, sir, not possible. What about symmetric? So symmetric may we have to follow the condition. If I go 2, 4, 2, 4, what is my other element? Of course 4, 2. Because in symmetric what happens? You AB and BA you write. AB and BA. What is HCF of 2 and 4? 2 only. And what is the HCF of 4 and 2? 2 only. Okay, so symmetric will be true. Symmetric will be true. What about transitive, sir? This is for this is to understand the reflexive part. This is to understand the symmetric part. Okay, guys. So symmetric answer is actually B itself. This was question number 2, by the way. Yes. All right. Why not transitive though? Why not transitive? Please check. Why not transitive, sir? If I go 2, 8, next one. Let's try this. 2, 8, what is the HCF, sir? 2. What is the HCF? Is 2. For 4, 8, what is the HCF, sir? Okay, no, I cannot do 4, 8, na? I cannot do 4, 8 actually. Sorry. I cannot do 4 because it will become 4, na? I have to keep both of them at 2 only. Sorry, excuse me. Excuse me, sir. Excuse me, sir. I'll try to make some other combination. So if I do with, let's say, 2 and 4, 2 and 4, and if I try with, give me example. Anyone with example? Come on, give me. Amina, Sahana. Yes. I want to prove it is not, because when I'm looking for transitive, no, there can be many options. So we'll try to look for where it is not possible. If you cannot find anything which is not possible, means it will be transitive. Okay. So in transitive, you try to go towards creating obstruction, creating opposition on the statement of transitive, not following it. Okay. So let's try to prove it is wrong. Let's not try to prove it is right, because it will be true for many places. Let's try to prove it is false. Okay. 2, 4, 4, 6. See. 2, 4, 4, 6, that is not right, because 2, 4 it is 2, 4, 6 it is 2, and for 2, 6 also it is 2. You can try for different numbers over here also. It's not like I have to keep 4 only over here. Yeah. We can try, let's say, 2, 6, and what we can try? 6 we have to keep over here because it is A, B, B, C only. So 6 and let's go with, okay, I have an idea. Yes. If I go with 4, 6, okay, then what is the HCF 2? Let's go with 6 and 12. But it will be what HCF as 6 actually. So we can try something else. Let's try 8. Let's try 8. 4, 6, what is HCF, guys? 2. For this 6, 8, what is the HCF? Also 2. The combination of this will be what? 4, 8. And what is the HCF here? 4. So here HCF is 2, here HCF is 2, but here HCF is not 2. Hence it is not a transitive relation. Clear now? So basically the way to go about in transitive is try to look for statements or the answer or examples where it is wrong. So question is what? Answered as option 2 or B. Am I clear? Am I clear? Yes. Okay. Cool. For any two real numbers A and B, we define A or B if and only if sin square plus cos square B equal to 1. So let's try to identify whether this is reflexive, symmetric or not. Okay. Is it my last question for this? Yes. So let me give you this as homework actually. This is question number 3, by the way. I'll keep it as question number 4 actually. I'll tell you. This is question number 4 and this is your homework. I'll give you a hint to do it because this is the last question of this type. I have 3 more questions as homework for your functions. This is one question as homework. Wait a second. So I'll tell you how to do it. So to find the symmetric, reflexive and transitive, right? Let's find the reflexive over here. How do you find it, bacha? So of course in the case of reflexive, the ordered pair is always A, A, right? So sin square A plus what will happen? This B will become what? Cos square A only, because if the AB is the ordered pair, if ARB is there, ARB means the ordered pair is what? A, B. But for reflexive, what is the relation? A R A. It means A comma A. So I have to replace the B by A only. Sin square plus cos square is how much? 1. So it is 2. Identity is there. So reflexive is true. Same way you have to do for symmetric also as well as transitive also. Okay. So please try to solve this. Just in symmetric, you have to prove that it is for, you have to prove it for this A comma B and B comma A equal. Over here you have to prove for 3 elements. Try. Otherwise I'm going to help you with this in the next class. Okay. Now next is the topic in this chapter, which is types of functions. So far so good. All going good. Clear, right? Okay. So next is 1 and so in types of functions we have of course many more types that you remember from the last year, but this is on the PU2 topic where we talk about only 2 varieties over here. On the 1 on 2, so basically it is 1 many 1 and onto and into. 2 types are there. Okay, we'll focus on that only. Okay. So 1 function and injective. Same name. You can see in the question it is written as 1 function, or sometimes it is written as injective mapping or injective function. They mean the same thing. I'll have to check on that. Santa, Mallikarjuna, I have to check on that. Okay, I have to check on that. Okay, let me get back to this question. So this property 1 function or injective function is the same thing. Sometime in the question they write it as mapping also. Sometimes it's written as mapping also, because mapping is the other name of function if you remember from PU1, right? Now what is 1 mapping? It means if you have, who remembers what is a function? So function is a machine which takes some input and give us some output. You take some input and give you output, and that is called as a function. This is a function. So arrow in, arrow out. Clear, guys? Yeah. Okay. So input and output. Function is a machine that takes an input, gives you an output. Example. Y equal to 2x. Y equal to 2x. If I'm writing this as a function, what happens? Check here. Input side, arrow in, arrow out. You take x as 1. What is the y value, sir? 2 into 1, so 2. X as 5. What is the y value, sir? 10. X as minus 5, minus 15, minus 30. So function is the machine that takes an input and gives you an output. And whenever you have a case where one element is mapped or related to only one element in the set B. This is my set A and set B. Set A is called what? The domain set, and set B is called as the codomain set. Okay. So whenever each element of the set A is mapped to or is linked to or is related to any one element in set B, only one element in set B, then this type of function or machine or mapping is called as 1 function. Is called as 1 function. Yes, equivalence relations are there in the KCET. Yes. So, is this clear? Amina, yes, equivalence relation is there. Very, very important. Okay. Alright. So, what did I say? Function is a machine or a mapping, you want to call whatever it is, which takes some input and gives you some output. Whenever each of these inputs or the element of the domain is related to only one element in the codomain, that type of function, that type of mapping is called as 1 mapping. Is it clear? Can you see 1 mapping? So whenever you have this, only 1 means if it is, sir, like this, 4 elements over here, they are mapped to only one element in the codomain. This is called as domain and this is called as codomain, or you can sometimes also call this as set A and set B. Next chapter will be, sir, ITF only. Okay. And when will be conducted, will be updated in the WhatsApp channel. So I hope you have joined the WhatsApp channel. Okay, so if you join there, you'll get to know when the classes are scheduled. Okay, let me get back to the next slide. Okay, many one function. So I think by now you all know. Okay, so if I have a function, sir, if I have a function and there is input side, which is the domain and codomain side, domain and codomain side, this is going in, this is coming out. And if you have, let's say, 4 elements over here, and you have what? You have over here what? Let's say 4 element or whatever is the number of element, and one of this is mapped to this, and even this is mapped to this only. This is mapped to this, and this is mapped to this. This is mapped to this. Then this will become what? And many one function. So many element to one element means more than one element in the domain will have the same image in codomain. That becomes a many one function. Example, my favorite, mod of x. How to draw the graph of mod of x? Where x defined for all real numbers. Please draw. This is the graph. So if you draw for an element, let's say I have y equal to 5, y equal to 5. So I'll get what? 2 values over here. Means when x value is, sir, minus 5, or when x value is, sir, plus 5, mod of minus 5 or mod of plus 5 is how much? 5 only. So whenever I can find those cases, those type of function where more than one value in x or in the domain side is mapping to one value in the or the same value in the codomain side, that becomes a many one function. Okay, chaliye. Now methods to check whether a function is one or many one. What is the method to check? So consider any 2 elements. So you'll check for 2 elements, x1 and x2. In the domain, of course, you can see here set A is written, and you put the value in the function x1. Okay, you'll try to find f of x1 equal to f of x2. Okay, and simplify this equation. If you get this also equal, it becomes 1 basically check here. If I write the function y equal to 2x, y equal to 2x, take here x1 value as 1 and x2 value as 2. Okay, and write here f of x1 equal to f of x2. Okay, what are you gonna do? F is what? Function is 2 into x. So write here 2 into what is x1? 1 equal to what is coming as 2 into 2. How much is that? 2 equal to 4. Is it possible? Of course not possible. This is not true. So you are getting, so if you start from this and you are getting this equal, it means it is 1. If it is not equal, it means what? Many one. It is many one. Okay, right guys, this is incorrect now over here. So this is a 1 function. I showed you over here also. This is a 1 function, right? And that's a many one function. Okay, all right. So let me erase this, not important. What is important over here? What is important over here? This is what important over here. If you start from f of x1 equal to f of x2, and you are getting what? x1 is also equal to x2. This is if statement and this is then statement. Then this is example of 1 function. Example of 1 function. If it is not equal, it becomes many one. Okay. If you take this as not equal and get not equal, that is going to be again 1 function. If you start with another one, let's say like this, f of x1 is not equal to f of x2. When x1 is not equal to x2, this is also example of 1. So what do you mean by this? Means if it is equal over here, this will also be equal. If it is not equal, this will also be not equal for the example of 1 function. Many one is just opposite. Equal, not equal, not equal, equal. Clear? Yes. And the other method is the graph, graph method. Means when you have a graph known and you take a straight line parallel to x-axis, when you get only one intersection, it is 1. The given function is 1. When you take the graph example of modulus function and draw this, you get example of many one. Can I give more examples, sir? Of course I can give. Let's take this, the graph of sine function. Draw a straight line. You have how many intersection? 1, 2, 3, 4. This is a many one function. This is the example of many one. Take a straight line. Example of 1, 1 function. So what you do to check? Draw a horizontal line parallel to x-axis and check the number of intersection. If you have only one intersection with one line, that is 1, 1 function. If you have more than one, that is many one function. So please have a note of this. Yeah. Now next case, which is the last case of this particular chapter, is onto function. It's onto function. So a function f is said to be onto. Again, what is a function? It is a machine. Okay. So for every element there will be some some thing present in the codomain, right? The mapping will be there. But if you can somehow leave something out, let's say we have these many mappings here and we have this over here. Let's say this is my domain, this is my codomain, domain and codomain. Okay, now start the mapping, guys. Start the mappings. How do you start? So sir, let's say this is the first one. You go this one also, then you have this one also, you have this one also, and yeah, correct. This is a mapped function. Now you can see this and this are left out. What it means is, one second, yeah, these two are left out. So what it means over here, guys, is what? It means if I write the codomain, in the codomain I'll have how many circles? 1, 2, 3, 4, 5. So I'll have 5 circles. 1, 2, 3, 4 and 5. Whereas in my range, if I'm writing my range, in range what I'll have? I'll have only 1, 2 and 3 circles, because only 3 are mapped. So in my range I'll have only 3 circles. And clearly these two are what? Not equal. So whenever range and codomain are not equal, or in the mapping something is left out, that type of function is called as, sorry, ulta. Oh, sorry. Yeah. Whenever something is left out, that is called as, yes, not an onto function. Or I went with the flow. This is example of into function. So not onto is called as into function. So whenever something is left out, that is called as not onto or into function. Right over here. But if the cases is for what? Everything is mapped out. For example, let's say, okay, so if I go like this, over here mapped, over here it is mapped, here it is mapped, and here it is mapped. Anything is left out? Nothing is left out. Nothing is left out in codomain. Okay, and this is the example of what? Example that your range is equal to the codomain. So if in whatever functions range and codomain are equal, those functions are called as onto function. And where it is not equal, this particular case, where it is not equal, that's called as into or not an onto function case. Clear? All of you clear? Yes? Satisfactory, guys? Yeah? So I understand my first class over here with all of you, with all the new students, so a little bit silent. But don't worry, as we move on, as we go on in this year, you'll become more. And I would like you to please be more vocal, ask your doubts, ask your concerns, okay? Because I understand I'm here teaching on YouTube, but still you're giving your time to me. So you have a responsibility to take action, to ask your concerns, ask your doubt. Whatever best I can do, I'll try to do it in the class itself. Okay, now methods to check whether a function f a to b is onto or into function. So first of all, as the method goes, find the range of the function if range and code b is representing codomain, because if I define a function like this, function a to b, define a function from a to b. What is the meaning of a? A represents the domain and b represents the codomain. Sorry, b represents codomain. B represents codomain. Now, A is domain, B is codomain. Whenever this codomain is equal to the range of the function, that is a case of onto function. In all the other cases, it is not onto, or it is simply into, or something which is called as, if you have other approach, what is it? If you try to put any value y equal to fx, this is basically solving it into obtaining x in terms of y. What it means? So any function which is given to you is given like this, y equal to fx. So that's what is the subject over here? X. You try to find a function x which is gy, means in terms of y. X in terms of y means what? You write x as subject. Usually y is subject, you writing x as subject, okay? And you take any value from the codomain. This means what? Any value from the codomain and try to put it over here. If x does not belong to the domain, it is not onto. It is not onto. I'll repeat. So for example, usually sir, function will be like this, y equal to fx, defined from a to b, where a is domain, sir, and b is codomain, sir. B is codomain. Okay, so what is they are trying to say over here is, try to find out, basically rearrange the function. For example, y equal to 2x we have, sir. Then I can write x equals to what? Y by 2. That's as simple as that, okay? So try to write the function as x equals to g of y, means some other function in terms of the variable y now, okay? And pick any element y from the codomain. B is what? B is codomain. So pick any element y. You'll know the codomain is given, right? Integer, natural number, whatever it is given, integer or natural number or whatever it is. Take a value from there and put it in this function, that value. That value. For example, in this question, if I take y equal to 2x, what is the domain? All real number. What is the codomain? Also all real number. Also all real number. So take any real number over here. Y equal to, I can take, let's say 5. I can take 5. Now I'll try to put y over here, 5 over here. So what is it? X equals to 5 by 2. And how much is that? 2.5. So for y equal to 5, my x value is coming as 2.5. X value is coming as 2.5. 2.5. And 2.5, if you check, is it part of the domain? Yes, it is. Domain is, sir, all real numbers. Is 2.5 a real number? Yes. So 2.5 is also a real number which is part of the domain. So if for the y from the codomain I get a x which is from the domain, then this whole setup becomes what? Onto. This whole thing becomes onto. Whereas whenever you are able to find the case where it is not equal, means when you find this and you get x does not belong to the domain, then this becomes a not onto or into function. So I understand this is a little bit something that is that can be troubling to your mind. So if it is something like that, please ask me in the comment section. Please let me know. Is it clear? Should I explain a little bit more? I've tried to take example and explain it, guys. Okay. Anyone? No? Okay. Now there's something called as bijective function. What is bijective function? Combination of both 1 1 and onto. Sometimes it is also called as injective, and onto name is called as surjective. The other name of onto is surjective. The combination of both is called as what? Bijective function. This is called as the bijective function. When both are true at the same time. A function f a to b where a is domain and b is codomain is called as 1 1 and onto, or bijection if both 1 1 and onto are means validated, means distinct element of a have distinct images in b. This is the case for 1 1 and each element of B is the image of some element in A, means nothing is left out. This is the case for onto. Clear? Okay. All right. Number of function. This is also very important for the CET point of view. Sometime in PY in the MCQs, questions on this appears. This is number of relation. I have not seen many questions in the PYQ of your boards, but number of functions sometimes they ask in the boards also. So number of function, the formula is n power m. What is the formula? N power m, where n represents what? The number of element in the set B, and m is the number of element in the set A. Okay, so the result is n power m. If you're looking for number of injections, sometimes they call it as number of injective mappings. What is the formula? npm, permutation of npm. Okay, so formula is n factorial by n minus m factorial. That's the relation for injective. This for relation for onto subjective. We have different result also for this. We use that in the question. I'll let you know. Okay, we have one question like that. And number of bijections is given as n factorial provided m and n are equal, provided number of elements are equal. Okay, now time to solve some questions. Yeah, this was question. This is actually question number 3, guys. This is question number 3. So homework are 4 questions. I'll give you the 3 at the last, and 4 I've already given. Okay, yeah. Let f be r to r be defined by fx equals to x plus mod x. Then fx is what? I want answers. Come on. The quickly you solve, the faster we can end the class and conclude today. And then you can let me know at the end how was the class. Yes, Sahana, all of you, please let me know the answers. Okay. F defined from r to r be defined by, the function is given like this. Basically, y equal to x plus mod x. Function is what? That's what they're asking us. No answer, guys. Come on, come on. It can't be this bad. Everyone, please tell me. Yes. No, sir, not in the mood today. All right, let me solve then. So what is it? Y equal to x plus mod x. So this is not a problem, sir, because they are saying that domain is all real and codomain is also all real. Okay. Not a problem, but this is a problem, sir, because this will change its sign. Mod x means what? Mod x means, sir, for all x value more than equal to 0, it is x only, but for x value less than 0, it will become minus x. Correct, na? For negative value of x, it will become minus x, sir. For positive and 0, it will be x only. Then try to write this function only. So if I try to write this for all x value more than 0, function y, what will happen? X will be x only, and mod x will become what? Again x. Correct? For all x positive, this will remain as it is, whatever it is. Okay, and this will be what? Mod x becomes positive x. So what is my answer? Y equal to 2x. And for x less than 0, what happens to the function? Check. So x will remain x only. It will not change sign. If x is negative, it will be negative. Positive, it will be positive. Okay. 1 second. So it will be x itself. And what about the other one? Mod of x. So it becomes what, guys? Negative of x. So plus minus x. What is the answer? X minus x, and this value is 0. So y equal to 0 is the answer over here. Okay, means I have 2 branches in the function. So if I draw this on the graph, please check. If I draw this on the graph, have a look over here. Okay, all right, let's try this. So this is the graph, because this is 0 over here. On this side it is what? Y equal to 2x. This is the curve. Y equal to 2x. And on the left side, which is the negative side, it is always 0. Y equal to 0 means what? This means x-axis, sir. Y equal to 0 is the equation of x-axis. So this is my curve. This is the arrows. For all positive value, graph is all the way up like this, and this is it. But tell me, is it 1, 1 on 2? 1, 1 or not? Check 1, 1. If I ask you, what is the function value at minus 1, you'll say answer is 0. Function value at minus 2, what is the answer? Also 0. Because for all the negative value, what is the answer, sir? Why? Always 0 only. It means it is not 1 1. Not 1 1. Okay. What about onto, sir? What about onto, sir? Look at the range. Look at the range. What is the range over here? Range is 0 to infinity. Starts from 0 and goes all the way till infinity. Right? Confused? Please check. This is all 0, sir. And this is going till positive side. Like this. So plus infinity. So this is my range. What is the codomain, sir? Codomain is given as all real numbers, which is going to be how much? Minus infinity to infinity. So negative numbers are missed out. Can you say range and codomain are equal? No, sir. These two are actually not equal. Range is only positive numbers and 0. Codomain is negative also. So they are not equal. It means the given function is not onto. So my answer is what? Option D. Hi Prachi. Do you have an answer? Okay. Clear now? Everyone clear with this one? Can I move ahead? Hello Prachi. Okay. Question number 3 is done. Now question number 4. Question number 4. Hello Prachi, how are you? Let the function f be defined from R to R. Fx equals 2x plus sin x. Now this is can you see this marking? Important questions. This is a very important and unique concept over here. So I would like your complete attention on this part. This is for purely CET. Okay, and this is a PYQ also. This is a PYQ of KCET. Okay, and it's an extra or good concept actually. So what you do in this question, you have to identify whether it is 1 1 or onto or not. But you have to use something called as derivative over here. Small concept, just listen to me. F dash of x. Derivative of, I know in your colleges they have taught derivative, basic derivative they have taught. Derivative of this function is what? 2 as it is, sir, and derivative of x is 1. Derivative of x is 1 and derivative of sine is what, sir? Cos x. So 2 plus cos x is the value of derivative. What I've done over here? I've done here, sir, differentiation. Differentiation. Derivative of x is 1 and derivative of sine is cos. Yes. Still we are supposed to get any update from the comment K. We have not received anything. As soon as we have any update, you will be informed, okay? Just be tuned in the WhatsApp channel for any updates coming towards you. And follow our, of course, our platform Diksha Karnataka. Okay, so f dash of x, 2 plus cos x is there. Derivative is clear, right guys? Now once this part is clear, understand this. Cos x can be maximum minus, like maximum 1 and minimum minus 1. That's the range of cos x function. Cos x function can go highest up to 1 and lowest up to minus 1. It cannot go below minus 1 or above 1. Clear? Good. It means if I take extreme cases, 2 plus minus 1, or other case 2 plus 1, this will be 1, sir, or this will be 3, sir. If you take here minus 1, it becomes 1. If you take here 1, it becomes 3. In both of the cases, this value will be always positive. Yes or no? If you take minus value for cos x, it becomes 1. If you take plus value, it becomes 3. In both of the cases, it is positive value only. 1 is also positive, 3 is also positive. When you have derivative always positive, this becomes a case of increasing function. It becomes a case of increasing function. Increasing function. What's the meaning of increasing function? Try to draw a graph of. Means always increasing. So like this or like this. So it is a function which is always increasing in nature. In all these types of function, if you draw a straight line, you'll always get only one intersection, guys. You'll always get only one intersection. That's why this becomes what? This becomes 1, 1. I'll repeat now. Please listen to me very carefully. You have the function, please differentiate it. 2x becomes 2, sin x becomes cos x. Cos x minimum is -1, maximum is +1. Take both the cases. It becomes 1 or 3. Both of these are positive value. Now the result, the important property is, if derivative of a function or differentiation of a function is positive, the given function is always a increasing function. In that case, what happens to the function? It is always increasing in nature. Look, if it is negative, sir, it will become decreasing. That is also there, but I'm not teaching you that over here right now, because when I teach you calculus, I'll teach that part again later. Right now, I don't want to teach you that. For this question, what is the important concept? Derivative is positive, increasing function. So draw the graph of all the increasing functions. It is always 1, 1, because if you draw a straight line parallel to x-axis, it gives you only one cut for any graph. It means the given function is 1, 1. Clear? One part is clear? Okay. Yes, Rujan. So please check. No, if you take, so this is derivative, right? 2 plus cos x. Cos x, can I have, to make it negative, I need -3, -2.5, something like that. Can cos x be less than -1? Tell me value of cos x less than -1. Rujan, come on. Tell me, come on. Tell me value of cos x less than -1. Any value, can you tell me? Sujan, let's come on, figure it out together. No, right? It's not possible. So if you put that value, the minimum value which is -1, it becomes 2 minus 1, which is how much? 1. So minimum value also is 1 and maximum value is always 3. So it is always positive only. Clear? That's why it is always positive, hence it is always increasing, hence 1, 1 function. Now what about onto? Onto is more interesting. Have a look. So try to take function, in the function I try to take x to plus infinity. Fx should also go to plus infinity only. Check. If I put here x as infinity, what happens? 2 into infinity, infinity only. And sin x is something what? Between -1 and 1. So infinity means a very big number. Let's take 1 lakh, or let's take 10 lakh. Okay, 10 lakh into 2, 20 lakh, plus 1 or -1. What happens? Close to 20 lakh only. Yeah. So this is again a very big number. So if you put a very big number, very big positive number, listen to me, very big positive number, in this it becomes still a very big positive number. So if x goes to infinity, fx also goes to infinity. And if x goes to negative infinity, fx also goes to negative infinity. Please check. Put a very big negative number. Minus 10 lakh. So minus 20 lakhs, sir. Plus sin x is either -1 or +1. Add or subtract. It will be again a very big negative number. So minus infinity. So in both of the cases, if both the cases are true, it means the function is extending to what? It means the codomain is all real and range is going to be also what? All real. Hence this comes out as onto function. Sir, I did not understand the last part. Yes, wait. If you extend the function towards right hand side, it is going all the way till infinity. So if I draw the graph of this function, if I go on x plus infinity, y also goes towards plus infinity, right? Y going toward plus infinity, and if I go x towards minus infinity, y goes till minus infinity. Yes or no? X towards plus infinity, y is plus infinity. Means if I check my range, what is my range, sir? Range is minus infinity to plus infinity. Check here, this is same as real numbers, which is equal to the codomain. And when range and codomain are equal, that becomes a onto function. So answer is what? That's why I said an important question, and it is a KCET PYQ. Clear now? Is this clear now? So So that's what the session that I plan for you guys. I don't keep it easy on purpose so that you will like me. I'm here to deliver content, the classes, the lectures, which is going to help you. It might be difficult. That's all right. If you're feeling the class is getting difficult, if you're feeling the question is difficult, I'm very happy actually. If you're feeling difficult, if you're still here, it means you are ready to learn. Whenever you try to learn something new, it is difficult. Have you tried? Think of it. When you started learning swimming, or went for a cycling class, went for a language speaking class. When I try to learn different languages, it's difficult for me. So when you learn something, things are going to be difficult, of course, right? But if you stay back and if you go through it, then you come out as a improved individual, improved student. So if it is difficult for you and if you're still here, I'm really proud of you. I'm super proud of you. Okay, just this, you got to watch it a couple of times, practice the questions, ask me your doubts, and then you will of course learn this, and then we move on to the next concept. Yeah, all right. So this is clear, guys. We'll check Sarath. Yes, I'll check on the Microsoft account. Yes, of course, I'll help you with that. Okay, you can, for now, what you can do is simply follow this platform, Diksha Karnataka, okay, and try to follow whatever instructions we are giving in. Will help you out. Certainly, we have enough time. Will make a good impact in the preparation. Okay, and if you're asking me for the book, MTG book, it is very good, but not all the questions are relevant for the CET. You should be able to figure out what questions to take. Not all of them are relevant for the CET. Yeah, but it is a very good book. It is certainly a very good book. But for now, try to get your basics of NCERT clear alongside the PYQ of each chapter that you are doing. So please take care of your boards aspect. Okay. All right. This is a question. This was a question number 4. So this is question number 5, sir. Set A has 3 elements and set B has 4 elements. The number of injections. What is it? Set A has 3, B has 4. So 4, P3. 4 factorial by 4 minus 3 factorial. What is the answer? 24, right? 24, na? 4 factorial is what? 4 into 3 into 2 into 1. So 12 into 2, 24. Answer is C. So if you know the formula, very quick answers. What should I do in maths for every chapter for question practice as NCERT feels irrelevant? Try to finish all the questions in NCERT. Even if it feels irrelevant, you'll find many questions directly from the NCERT in the CET also. And one more thing, miscellaneous exercises, please try to solve the questions. So NCERT, all the problems, even though it is very easy. Miscellaneous questions and exam plus, guys. Exam plus are very important. Okay. Yes, Sarath, few people have told me. I'm gonna go and check it out, what is going on, and we'll resolve it. Okay, we'll see what we can do. Okay, question number 6 now. Which of the following is 1, 1? So graph, if you know, you'll know the answer. E par x is 1, 1, sir. Graph of E par x is this, sir. Anywhere you take, it will be always a unique intersection, sir. So answer is clearly A. Don't even waste a second on it. Okay? Yes. So that's why the graph of various functions becomes very vital over here. Next. So this is clear? Yeah, 6. Then question number 7. If A is given as, okay, so it's given in the form of set builder, notation for the set, all x less than 5, natural number. So let's try to write A then, natural number less than 5. So we have 1, 2, 3, less than equal to, so 4 and 5. This is natural number less than equal to 5. So 1, 2, 3, 4, 5. And set B. What is it? X square minus 5x plus 6. If you factorize it, you will have x minus 3 and x minus 2. Am I right? Because plus 6, check here. Multiply these two will become plus 6, which is over here. Minus 3x minus 2x, which is minus 5x, and x into x is x square. So correct. So from here I get element as 2, 3. 2, 3. They're asking us to find number of onto mappings. Number of onto mappings. Again, there is a big formula that I've given you. The logic that works over here is for onto mappings, you find the number of total functions. So you'll have what? Yeah, in this case 2 power 5. 2 power 5 will become how much? 32. Okay. Here 2, here 5. 2 power 5 is 32. Okay. But for a case, check here guys, check here. For the case where you are write 1, 2, 3, 4 and 5 and we have 2 and we have 3. If I map all these elements to 2, in this case what is happening? 3 is left out. What is happening? 3 is left out. Yes or no? If I map all these elements of domain to 2, 3 is left out. Is it onto, sir? Not onto. So I have to remove this particular case from 32. So remove that. From 32, sir, remove -1. And what about the other case? What is the other case? When all of this is mapped to 3. Also not onto, so remove another case. So for a function where every result is mapped to 2 and a function which is all result mapped to 3, those 2 cases I have to remove. So I have removed 2 cases. So my answer is nothing but 32 minus 2, which is 30. B is the answer. Yes. Yes, Microsoft, thank you for giving that lovely comment. Should I solve paid batch TPPs? I have lectures from offline as well. Is it enough for 1000 rank? So try to, I'll tell you what, try to be less chaotic in the process. Okay, try to keep the process very simple. Okay, if you go full chaos in the process only, it'll become very hectic. So as I mentioned, NCERT, solved examples and some good questions you should solve. Miscellaneous you should solve. Exemplar questions, good ones we can solve. Okay. Now, apart from that, if you are enrolled in some other courses where you're getting a quality DPPs, quality content, please try to take those questions and solve it. Okay. And yeah, KCET PYQs keep in your practice. And not only that, for top 1000 rank, what happens? You need to be able to score 95% plus marks in boards. So please remember that, very, very important. And for CET, 150 plus a score. 150, 160 score you have to score in 180. That can only happen if you are practicing for CET every time, means you are having practice sessions in your day, every day planned for CET, even for 1 hour. Okay, so plan that and try to keep a timer with you so that you are practicing whatever questions you are practicing. So 1 question, 1 minute, that is it. 30 questions you are practicing, good, 30 minutes. But for that you need to make sure the question is for CET level only. You cannot solve board question in 30 minutes. You cannot solve JEE main question in 30 minutes. So that's why I'm saying PYQs try to attempt. You'll get more idea about it. Or just KCET questions if you have a source like that. Okay. But time to practice. KCET type questions, 1 question, 1 minute. If you're able to follow properly, you can get top 1000 rank. Yes. Let's get back to the question over here. So previous one, no doubt guys, 7th one, answer is 30. Why did I remove the 2 cases? Because if all the numbers are mapped to 2, then 3 is left out. So not an onto function. And all of this is mapped to 3, then 2 is left out, not an onto function. So remove both the cases, it becomes 30. So question number 8 now. Let A be this. X is not a positive integer. Okay, the function given over here, write it again. It's given as y equal to 2x upon x minus 1. 2x upon x minus 1. Check it is injective or not. Check for 1, 1 first. For 1, 1, what do you do? You start from here. F of x1 equal to f of x2. Try this out. 2 of x1 upon x1 minus 1 equal to 2 of x2 upon x2 minus 1. 2 and 2 cancel, sir. Simplify this. Okay, simplify this. Cross multiply. You get x1 into x2 minus 1, x2 into x1 minus 1. What I've done? Cross multiplication. Okay. This to this and this to this. Check. I'm getting over here x1, x2 minus x1 and x2, x1 minus x2. Check, this 2 are cancelled. x1, x1 x2, x1 are cancelled. Now I have minus x1 equals to minus x2. You can cancel the minus sign also. The result is giving me what? x1 equals to x2. What did I say? If you have equal to over here and equal to over here, it means the given function is 1, 1. The given function is 1, 1. What about onto, sir? I said this already. Try to write y equal to this function and make subject as x. How do you make that? Cross multiply. X minus 1 into y equal to 2x. Open the bracket. You'll have xy minus y equal to 2x. Yes, xy minus y equal to 2x. And yeah, we'll move this y over here and this over here. We'll get xy minus 2x equals to y. Let's take x common. You get y minus 2 equal to y. So x equals to y upon y minus 2. Please cross check. Simplification, okay? Just cross multiplying these two over here. And then expansion, moving y and moving 2x on this side. Minus 2x, take x common. Now, you started with y as subject. Now you have x as subject. What is the function now? X equals to y upon y minus 2. Y upon y minus 2. Let's check. What it means is, if you try to find condition of y over here, y cannot be equal to 2. Because if you put y equal to 2, it will become undefined, right? And x cannot be undefined, right? So I have to put y not equal to 2. So if you check over here, my range I can find. What is my range, sir? Range is all real number except for 2. All real number except for 2. And what is the codomain? Codomain is given here. What is the codomain? Codomain is given as all real. So codomain is given as all real. Clearly, these two are not equal, sir. These two are not equal, sir. So range and codomain are not equal means not onto. So answer is 1, 1. Not onto. So injective but not surjective. Option is A. I'm sorry if you feel the question is difficult, but this is a PYQ of CET. This is a PYQ of CET. Yes, Amina, your answer is right. Great. Yeah. So 8. Okay. Okay, let me just check. I think I had some homeworks for you guys. Yeah, this is the last question for the day, and then I have 3 homeworks for all of you. Okay. So question number 9. A is a set having 6 distinct elements. The number of distinct functions from A to A, which are not bijection. So number of functions we'll find, and number of bijective function if we can find. What are they saying? You have to find out number of function which are not bijective. Which are not bijective. So you find a total number of function, and from there you remove the bijections. They're saying number of element is what? 6. Will become what? 6 power 6. 6 power 6. That's by number of functions. Remember in the previous case I wrote 2 power 5. 6 power 6 here. And number of bijective function, what happens to this number of bijective function? It is nothing but 6 factorial. So from the number of function I want to find out those function which is not bijective. Subtract them. Subtract them. So answer is C. Answer is C. You're welcome. Microsoft account 9. Okay. Now homework question. So I have already given the homework. I'll show you again. This is your question number 1 as homework. Okay. Question number 2 as homework. Acha guys, please take a screenshots, okay, if you want to. Question number 1 is homework over here. This is on 1 on 2. Question number 2 is for homework again for number of functions. Question number 3 is homework again for 1 on onto function. This is for 3 questions on functions, 3 questions for functions, and 1 question on types of relations I've given. Okay, types of relations I've given. So I'll show you that also. 1 second, it's right here, I guess. Types of relations. Where is the question? It's here. This is your 4th homework. Please check. This is your 4th homework. Yeah. So this is clear. Now, so this is very important because I would like to know, this is total homework by the way. So I would like to know the number of students who are actually attempting it. I would like to know your names because this is my first class in this year, okay? So my first class, I want to know my students that who are sincere about it, okay? Whom I will of course give more time, more efforts, okay? So things will become, even though it is an online platform for free on YouTube, but we can build a relation over here also, right? So that can be done easily if I can track your work. So try to give a fair attempt. Come here, ask your doubts. It'll be fun for me also, and fun, trust me, it'll be a right learning curve for you also, okay? So only 4 questions have been given. Solve these. When I come for the next class, I'll ask you all. I'll keep the question slides and I'll ask you to please help me with the answers, and I'll also explain you those questions. So I'll try to keep that. So I'll try to do it. If you are not responding, then I'll stop it, okay? But if you are responding well, then of course I'll try to incorporate this every class. When I come, I'll keep the homework slides and I'll check what is the answer you got. Yes, yeah. So I hope it makes sense. All of you, how was the class? How was the class? So this was it in the class today. Yeah. I've discussed both the concepts, which is important for CET. Now let me know how was the class. Your first class from me. I hope you remember me. If you don't know me, my name is Ankith. I take maths classes on our channel, Diksha Karnataka. If you have anything to ask me, feel free to do so. Okay, I'll be always here to help you, support you in all the way possible. In maths especially, as well as in academics, whatever I can do to assist you, to help you with, I'll not shy away from doing that. Okay? Yes. So let me know how was the class. And one more very important, so by the time you are typing your comments in the live chat, I would love to know all of your names. So I know 2 people today. Amina was there and Shahana was there. 2 students' name I remember. IDs is difficult to remember. One more is there. Microsoft accounts, if you guys tell me your name will be better. Okay, but yeah. 2 people name I remember. Now I would like to tell you one more thing about, so you were concerned, no sir, from where I'm studying, this is there, which questions to solve, all the concerns that you have, I have an answer for all of that. That answer is this. Pariksha Veera. It is our full year batch, okay, for the next year, especially for KCET. Everything which you need is already present in this batch, okay? In this you get 110 hour plus lectures for physics, chemistry, maths and biology, okay? So all of this is incorporated, means 110 for this each. 110 hours of each, okay? You have classes, schedule is all given, link you'll find for this batch in the video's description, so go ahead, check it out. You'll get more details over there, and the price for this also you can check. It is price also is available. You can check in the description of this this particular video. You'll find the link. Go and check it out. It's 3499, I think. Yes. So all the answers, whether it is PYQ solving, question of CET, test, all of this, 20 plus tests is there, part syllabus, full syllabus, PO2 syllabus coverage, all of this is done for boards and CET together, because boards is very, very important. Never neglect the board, okay? Because it is easier, it is easy to score marks over here, so never neglect the board, okay? If it was less weightage, first of all, board is easier and equal weightage than CET examination also. So do not, if you're preparing for CET, don't prepare for the exam that will happen in the April. Prepare right now for boards also. Very, very important, okay? Yes. So yes, guys, how was the class? Anything else you want to ask me? The batch is available. Class already started actually, but not way back. Only 6th July was the first class, the orientation. This was our first class, which was yesterday. So we had a wonderful session over there. Many students joined, and in the batch orientation was there. There was a physics class yesterday. Today also we had physics and chemistry class. So if you're planning to do so, do it quickly so that you don't have too many backlogs. Try to take up as soon as possible. Yes. The batch name is Pariksha Veera for KCET 2027. Okay, if nothing is there, if you don't have any other concerns, I can end the class. All right, so it was nice getting back to know you all. Few of the seniors of yours, means my previous batch student came, which I taught them last year on YouTube, and in the paid courses also. Glad to get the opportunity to interact with them and also get to new students, all of you. Of course, as we go along, we'll make a lot of we'll have a lot of fun. We'll work harder together. I'll help you, you help me, and we'll have a proper learning, and we'll achieve our dreams together. Okay, so that's all in this class. Anything else you have to ask me? Even if this live is over, you can always put that in the comment section. I'll be replying to your comments. Okay, if you know me, you know that I reply to your comments. If you don't know me, it's okay, don't worry about it, but put your concerns in the comment section. I'll get back to you all. Okay, that's all in this class. Had fun teaching you all and love the opportunity to teach you again. So see you all in the next class. Take care. Bye bye. Go rest, have some dinner, and see you in the next class. Okay, take care. Bye bye.